Hello students. Today we are going to learn an extremely important topic of reasoning, pattern and spatial reasoning. This topic tests your ability to understand visual patterns, mentally rotate objects, identify symmetry, solve cube problems and analyze three-dimensional figures. So let us understand all major concepts step by step. Pattern and spatial reasoning means the ability to observe, analyze, and mentally manipulate shapes and patterns. In simple words, you must understand how figures change, rotate, fold, reflect, or combine. These questions check your observation power, logical thinking, and visual imagination. This skill is very useful in engineering, architecture, design, military aptitude tests, and competitive examinations. There are many types of pattern and spatial reasoning questions. Some questions ask you to complete visual patterns. Some involve symmetry and reflections. Others test your understanding of three-dimensional rotation and cube orientation. You may also see questions related to nets of solids, cross-sections, tessellation, maze solving, and block counting. Understanding the logic behind each type is the key to solving them quickly. Visual pattern completion questions usually contain a matrix of figures. You must identify the hidden rule. The rule may involve rotation, shading progression, increase in number of shapes, or combination of figures. One very important rule is the XOR rule. In XOR, common elements cancel each other and only different elements remain. Always check rows and columns carefully before selecting the answer. Symmetry means a figure can be divided into equal matching parts. In line symmetry, one half becomes the mirror image of the other half. For example, a square has 4 lines of symmetry, while a rectangle has 2. Rotational symmetry means the figure looks the same after rotation. For example, a regular hexagon has rotational symmetry of order 6. Point symmetry occurs when a figure looks the same after 180-degree rotation. Spatial visualization means mentally converting two-dimensional figures into three-dimensional objects. You must imagine how an object looks from different directions. There are 3 important orthographic views. Front view shows height and width. Top view shows width and depth. Side view shows height and depth. These concepts are very important in engineering, drawing, and aptitude tests. Three-dimensional rotation problems are very common in exams. In these questions, a cube or object is rotated in different directions. You must track the movement of faces carefully. For example, when a cube rolls to the right, the left face becomes the new top face. One important rule to remember is that opposite faces always remain opposite after rotation. Never try to perform multiple rotations together. Solve one rotation at a time. A net is the unfolded form of a three-dimensional solid. When folded properly, the net forms the original solid. For cubes, there are exactly 11 valid cube nets. 2 important rules help eliminate wrong options quickly. First, a valid cube net cannot contain a 2 by 2 square block. Second, it cannot have more than 4 squares in one straight line. Always imagine the folding process step by step. A cross-section is the shape formed when a solid is cut by a plane. Different cutting directions produce different shapes. For example, a horizontal cut through a cylinder produces a circle. A vertical cut produces a rectangle. A vertical cut through a cone gives a triangle. And interestingly, every flat cut through a sphere always produces a circle. In block counting questions, you must count both visible and hidden cubes. The column method is the easiest approach. In this method, you count the height of every vertical column and add them together. Sometimes questions ask about hidden cubes inside a solid cube. For a solid n by n by n cube, hidden cubes are calculated using the formula open bracket n minus 2 close bracket whole cube. Tessellation means covering a surface without gaps or overlaps. Only 3 regular polygons tessellate alone: equilateral triangles, squares, and regular hexagons. In path tracing problems, we use Euler's rule. If a figure has 0 or 2 odd degree vertices, it can be traced without lifting the pen. If there are 4 or more odd vertices, tracing becomes impossible without retracing. Students often confuse reflection with rotation. Remember, a reflected figure is a mirror image, not a rotated figure. Another common mistake is forgetting hidden supporting cubes in block counting problems. In matrix questions, many students identify only one rule and ignore the second rule. Always verify the pattern carefully across both rows and columns. So, students, today we covered all major concepts of pattern and spatial reasoning, including visual patterns, symmetry, spatial visualization, three-dimensional rotation, nets of solids, cross sections, tessellation, and path tracing. Practice these concepts regularly because visual reasoning improves mainly through repeated observation and problem solving. Thank you, students. Jai Hind.